Hi guys, welcome to my YouTube channel, and in this video we're going to discuss about alkenes. Please like, subscribe and share. So alkenes belongs to a group of organic compounds that are known as hydrocarbons, and alkenes have a double bond, carbon-carbon double bond. So they are sp2 hybridized, and they are said to be unsaturated hydrocarbons because they have a double bond. So you're going to look at reactions that includes alkenes. So the first thing that we need to discuss is when large molecule, for example an alkene, is broken down in a process called cracking, you get a mixture of an alkene and alkenes. So alkenes are formed in this way. So a large molecules, for example the decane that is displayed there in presence of aluminium oxide, it forms a mixture of an alkane and an alkene. The alkane is hexane, and then we have the alkene, which is butane. So when you have large alkanes, then you break them down into smaller alkanes. In the process of cracking, you are able to get alkenes. So alkenes are formed through the process of cracking and the process of elimination of hydrogen halide, or elimination of hydrogen halide, for example HCl from a halogenoalkane by heating it with ethanolic sodium hydroxide. It can also be formed by dehydration of an alcohol using a catalyst such as aluminium oxide in presence of concentrated, or maybe a concentrated acid, for example sulfuric acid. So dehydration basically is elimination of a water molecule from a compound so that you form another molecule. So alkenes are formed in that way. So here we have general reaction involving alkenes. So it's an alkene that is you react an alkene. Alkenes, we say they are very reactive. So you react an alkene in presence of a substance XY to give you alkene, an alkane that has X and Y in it. And then you have another one, the one that you form like molecules. You have an alkene reacting with a ZZ molecule, therefore you'll get an alkane in that matter. So the first kind of reaction that you're going to discuss is hydrogenation reaction, or basically addition of hydrogen in an alkene. So when a hydrogen gas and an alkene are heated, or if it's passed over finely divided platinum catalyst, so you have platinum catalyst or nickel catalyst that is used in this case, so you'll get an alkane, which is, for example, you have ethene, then you pass hydrogen or react it with hydrogen in presence of platinum or nickel catalyst, you're going to get an alkane, which is ethene. So hydrogenation is an important reaction that is used during hardening of fats, or hardening of oils to become fats. So at room temperature, for example, if you react an alkene with a hydrogen halide, for example hydrogen bromide, then you are going to get bromoethane. So if you have ethene, you react it with hydrogen bromide, you form bromoethane. So if you react again with a symmetric alkenes, so you have two products that you can form. For example, if you have propene, you react it with hydrogen bromide, you are going to get one bromopropene, or you can also get two bromopropene. So it is important to note that where two addition products are possible, the major product is the one that has halogen atom bonded to the carbon-carbon bond. The one that has a halogen atom bonded to the carbon-carbon atom, bond atom with the highest number of alkyl groups bonded to it. This is because the group that the carbon that has more alkyl groups bonded to it will have inductive effects, and therefore it will form the most stable carbocation. So if you have two reactions of propene, for example with HBr, the bromine will bond to the central carbon atom, forming the major product. So you have the central carbon atom is bonded to two alkyl groups or two methyl groups, so therefore they make it more stable. So therefore you'll get two chlorobromine, two bromoethane, propene as the major product. So remember, the most stable carbocation is the one that has more alkene groups bonded to it, and therefore it has the most stable intermediate. So the most stable carbocation mostly is the secondary carbocation or the tertiary carbocation. So in this case we have a reaction between propene and hydrogen bromide. So the most stable carbocation that will form bromopropene is the secondary carbocation. The secondary carbocation is the one that is bonded to two other alkyl groups. So like the second carbocation is bonded to a methane on one side and another methane on the other side. Therefore it is the most stable carbocation, and therefore it's the one that is attacked by the bromine ion, forming 2-bromopropane. Let's look at addition of steam. So steam is water in vapor form. So scientists in the industries, they use this addition of steam to alkenes to make alcohols. So they react steam and the gaseous alkene at high temperature and high pressure in presence of concentrated phosphoric acid. Then they form an alcohol. So when alkene, for example ethene, is reacted in phosphoric acid, they will form ethanol, an alcohol of that alkene. So an example is displayed there, where you have an alkene, which is ethene, reacted with water in presence of phosphoric acid. That we've said that water in gaseous state to form ethanol. So if it's ethene plus steam forms ethanol, which is an example of an alcohol. Addition of halogen. Halogens, they are atoms in the group 7 of the periodic table. So it's like chlorine, bromine, iodine, etc. So they are known as halogen. So if we bubble an alkene through a solution that has chlorine or bromine at room temperature, we therefore get, that's an example of an addition reaction, and you'll get either a bromoalkene or a chloroalkene. For example, if you bubble an alkene through a solution containing bromine gas, then you're going to get 1,2-bromoethane. 1,2-bromoethane. So if you react the alkene with chlorine, which is usually a pale green solution, that is chlorine water, so you will get that the chlorine water is decolorized in the presence of an alkene. If you bubble through bromine water, which is orange in color, bromine water is decolorized. Bromine water is decolorized by the presence of an alkene. So let's look at the mechanism of electrophilic addition reaction of an alkene. So there are 4 electrons in total formed in the carbon bond. So we have in ethene, for example, we have a sigma bond and we also have a pi bond. So ethene, we say it's an unpolar molecule. A polar molecule is the one that has electrons being pushed to both ends. So there is a high electron density in between the carbon-carbon double bond, making the alkenes very open to attacks, and therefore we find that in most industries, scientists use alkene reaction to generate many products. So the high electron density in the carbon-carbon bond in alkene makes it very much attacked by molecules. So an electrophile is an electron acceptor, or it accepts a pair of electrons from another molecule. So you have HBr, which is hydrogen bromide, is a polar molecule because of the difference in electronegativity between the hydrogen and the bromine atoms that are forming the bond. So in that molecule of hydrogen bromide, a hydrogen atom has a partial positive, of course, and the bromine atom has a partial negative charge. So if you have a mechanism in addition of hydrogen atom to hydrogen atom will act as an electrophile, which is an electron acceptor. So it will accept a pair of electrons from the carbon-carbon double bond in the alkene. So bromine will act as an electrophile. So the reaction, so there is a high charge density between a carbon-carbon bond. So there will be repulsion of a pair of electrons between the bromine bond, and that is the bromine. One of the bromine carries away the electrons, so the bond will break down heterolytically. The bond will break down heterolytically. So there you have the reaction mechanism where you have the electron, the high charge density between a carbon and carbon bond. The electrons will be carried away by the bromine. The double bond will attack one bromine, and then the bromine will carry away the other electrons. So the bromine will attack the carbocation with a positive charge, forming 1,2-dibromoethane. Don't forget to subscribe and like. Follow me for more videos on organic chemistry. Thank you.